Hello, in this lesson I want you to analyze and graph rational functions. I want you to solve rational equations. So vocabulary we're going to be looking at is a rational function, an asymptote, a vertical asymptote, a horizontal asymptote, an oblique asymptote, and wholes. So we're going to spend the first part of our lesson talking about graphing rationals. Now just remember, a rational function means a ratio of polynomials. That's all it is. And because we have a ratio here, we can't divide by 0. So anytime your denominator goes to 0, that's not going to be part of your domain, and you're going to have a vertical asymptote. Now the end behavior of a function is what happens is x approaches positive infinity or negative infinity. So that gets pretty simple if we just think about what that graph means. So if I take a look at example 1 here, first thing I want to do, I look at my denominator. When does x minus 3 equal 0? Well, x minus 3 equals 0 when x equals 3. So what happens is you're going to have a vertical asymptote at x equals 3. Now let's talk about a horizontal asymptote. What happens as x gets really, really big? Well, but essentially I've got infinity, because if we take a really big number and add 4, you got a really, really big number, all over the same number. If I take a really, really big number and subtract 3, I've still got a really, really big number. So in other words, my horizontal asymptote is going to be at y equals 1. So here are our two asymptotes. Now we can check this by graphing that function. And here I've got the graph for us. Now it's you can kind of see x equals 3, but it's kind of hard to see that y equals 1. So if I if I graph the line y equals 1, get that color to show up there. There you can see it. The graph does not cross at 1. And there we have it. Let me shut off these other two graphs. Now, let's take a look at example 2. When does your denominator equal 0? Well, notice it will never equal 0 unless we're talking about complex numbers. So in other words, there is no vertical asymptote. Now if I look at my horizontal asymptote, I'm going to take 8 times a really, really big number and add 5. In other words, it's 8. All over 4 times a really big number and add 1, so it's 4. So I'm going to take 8 over 4. So I have 8 times a really, really big number divided by 4 divided by a really, really big number. So I get 2 times a really, really big number. So in other words, I should have a horizontal asymptote at y equals 2, because 8 divided by 4 is 2. Now we can check that one also. So let's graph this function. Here's my function. And whoops, it was there for a second. Oh, we can definitely see there is no vertical asymptote, is there? And it looks like there's a horizontal asymptote at 2. It gets really close to 2 right away. And there is your answer.